Okay, so now we're dealing with the exceptions to the octet rule. All right, let's go ahead and crunch the numbers for phosphorus pentafluoride. Okay, everybody needs 8. The N value for all of these guys is 8. So 8 times 5 is 40. Oh, well, we'll just do 48. Okay, 48. 8 times 6 is 48. Available phosphorus is 5. And then fluorine is 7. Remember, it's got 7 valence electrons. 7 times 5 is 35. 5 is equal to 40. Okay, so 48 minus 40 is equal to 8. Okay, so here's where it gets interesting. According to this, you should have only 4 bonds, right? Because 48 minus 40 is 8, divided by 2 each. Remember, each bond is 2 electrons. So this is saying that we have to have 4 bonds. But we can see here that we have 5 peripheral atoms. If phosphorus is in the middle, we're going to have 5 fluorines around it. So we need 5 bonds. So this is what you have to do in this situation. You have to tweak it. You change that 8 to 10. It's the only thing you're going to change is this guy over here. You're not changing these guys. You're just changing the shared. Okay? So now we're saying, yep, we need 5 bonds because we know we have 5 peripheral atoms. Okay, you're not going to do this so that you can create extra double bonds or anything like that. No, you only do this in a situation where your S value is too little, okay, too few. Then you have to increase it. I think maybe there is one weird scenario where your S value is too many and you have to bring it down, but I don't know if you actually see it in this class. But for this, yes, you will be seeing this, where your S value is too little, you have to make it bigger. Okay, so we're going to put the phosphorus in the middle, and we're not learning any shapes right now. We're going to learn shapes in the next chapter, but right now it's okay that I make it look like a flower like this. It actually looks a little different than that. All right, so I've got my 5 bonds. 40 minus 10. Now it's not going to be 40 minus 8 anymore. It's going to be 40 minus 10. 40 minus 10 is 30. So I distribute the 30 all around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. What you can do if you don't feel like putting the dots is just draw lines, and a lot of people will do that. They'll just draw line, line, line. I like to draw the dots because to me, that reminds me that these guys are the lone pairs. They are the non-bonding electrons, and everything else is bonding. So for me, I put lines for the bonding electrons and dots for the non-bonding electrons. Okay, let's do another one. Let's do, this is still under the big heading of exceptions to the octet rule. Let's do sulfur hexafluoride. Sulfur hexafluoride. Okay, so S is equal to N minus A. Your N value, everybody's 8. Remember that. So we have 6 times 8 and plus another 8. So that's 48 plus 8. That is 56. Okay, 7 times 8, 56. Okay, what about the available? Sulfur is 6. Fluorine is 7. 7 times 6 is 42. So 42 plus 6 is 48. Hopefully I've got my math right. Okay. Now, 56 minus 48. That is 8. Do you think that's right? No, can't be right. Why not? Because you've got 6 peripheral atoms here. Just like we had with the phosphorus pentafluoride, over here with the sulfur hexafluoride, you've got 6 peripheral atoms. This is telling you you can only have 4. So we have to change that. What are we going to change it to? We want 6 bonds. So if we want 6 bonds, this number has to be 12. Exception to the octet rule, okay? Why is this okay? Because sulfur and phosphorus are in a period that has the D zone. So they start using the D zone for bonding, okay? All right, so we're going to put the sulfur in the middle, and we're going to put 6 fluorines around it. 1, 2, 3, 4, 5, 6, and we're going to draw 6 bonds. Okay, so how do we know how many are remaining? 48 minus 12. So that is 36 electrons are remaining. 48, remember, the A value minus the shared value gives you the remaining electrons. So we distribute these as pairs around the peripheral atom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Boom, you are done. If there were any remaining, you would have had to dump them on the central atom. So you'll see that in the next one. Okay, let's do one more. All right. This one will be an interesting one. Xenon Tetrafluoride. And you'll say, but Dr. Wabi, xenon is a noble gas. What's it doing bonding? Yep. When you've got these noble gases that are the heavier ones, they can do covalent bonding. Their N value is 8 and their A value is 8. So everything's 8 for them. All right, so let's go ahead and do it. S is equal to N minus A. N, everybody's 8, so we have 5 times 8, that's 40. A, these guys are 7. 7 times 4 is 28. And then we said this was 8, so that's 36. So 40 minus 36 is 4. This is telling me that I can have only 2 bonds. Is that okay? No, because we've got 4 peripheral atoms. So we're going to change this 4 and turn it into an 8 so that we could have 4 bonds. Okay, good. Who are we going to put in the middle? We're going to put the xenon in the middle. Xenon in the middle. And that's a weird one. Like, why are we putting the xenon in the middle? It doesn't even need any electrons to fulfill the octet. This doesn't make sense. It's definitely less electronegative than fluorine, and it has that D zone that it can use. So we always put that xenon in the middle. Just remember that, okay? And remember how I told you fluorine's never in the middle? So there you go. There's that. All right, so let's put our 4 fluorines around. Okay, and how many do we distribute now? So it's not 36 minus 4, it's 36 minus 8. 36 minus 8 would be 28. So let's distribute 28 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Where do I put the rest? On the central atom. Anytime you distributed all the electrons around the peripheral atoms and you still have some left, you dump them on the central atom. So we are at 24, 25, 26, 27, 28. Exception to the octet rule. It's carrying more than 8. Okay, let's do the last one, and then we will, in the next video, talk about formal charges and bond energy, and then we should be able to wrap up this chapter. Okay, let's do this. I3 minus. So this is a triiodide polyatomic ion, okay? And we need to do the Lewis structure for it. All right, so S is equal to N minus A. N, everybody's 8, remember. So 3 times 8 is 24. Iodine is 7, and I have 3 of them. 7 times 3 is 21. But look at the charge. Remember what I told you guys. Anytime there's a charge, you add those electrons. If it's a negative charge, you subtract the electrons if it's a positive charge. So 21 plus 1 is 22. So 24 minus 22 is 2. So this is saying that I should only have 1 bond. Well, I've got 2 peripheral atoms. One of the iodines is going to be in the middle and the other 2 are on the periphery. So I have to change the 2 and turn it to 4 so that I could have 2 bonds. Okay, so I'm going to do this. Put an iodine, iodine, iodine. Okay, now I have my 2 bonds, the 4. I counted for the 4 electrons. Here's 2 and 2, 4 electrons shared. Okay, so how many electrons do I have remaining? 22 minus 4 is 18. All right, now let's start to distribute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Where do I put the rest? Now we can put them on the central atom. 12, 13, 14, 15, 16, 17, 18. Because 22 minus 4 is 18. We have to distribute the 18. We distributed the ones on the periphery first until everybody had an octet, and then everything else had to be dumped on the central atom. Is this an exception to the octet rule? Absolutely. Is it okay that it's an exception? Yes, because iodine has the D zone that it could use, okay? Anything that is beyond, like first, second period, no. Anything that's in the third period and heavier can have exceptions to the octet rule. Since it's a polyatomic ion, we'll put this and do this, and you are done. Okay, I think I've given you enough examples of the exceptions to the octet rule. And like I said, we are ready to move on to the concept of formal charges, I think. Yep, yeah, we'll do that in the next video.